Today I will show you how to do this meteorology question in wind engineering. The original author of this question is Dr. Graham Wood in Iraq, Australia. So let's read question first. The Sydney region is exposed to a sea breeze in hot summer afternoon. A vertical profile of 10 minutes mean wind speed and direction measured at Sydney Airport are presented in figure 1. So this is the point at Sydney Airport. And this is the horizontal wind speed, respective to height. And this is the wind direction. And we can see that the wind speed swing a little bit and change in wind direction as well. So this is noon to 6 p.m. and this is 6 p.m. to the midnight. Okay, then first question, describe the physical mechanism producing a sea breeze and include typical vertical and horizontal extent. So the key point over there is the temperature difference between the sea and the land. So let's draw. So we assume that the sea, and we draw land over there. And the main difference is in hot summer, the land will rise up quicker. So it will rise up quicker. Then the hot air will rise up. And it will create a relative low pressure zone near the surface. So the air will blow to the land near the ground, and you can see the circulation will be formed. And so this is the physical mechanism of a sea breeze in typical vertical and horizontal extent. So the vertical is about 300 meters. And horizontal is about 20 kilometers into the land. Okay, so this is able to get the full 3 marks. And question B, discuss the observed development of the flow pattern presented in figure 1. We already did. And how does this align with the sea breeze? So if we observe the figure over there, the first thing we can see that from noon to 6 p.m. is mainly north wind, and 6 p.m. to midnight is still north wind. So there's no shift in the wind direction. Or we can say no big shift in wind direction. And another point we can see is the mean wind speed, 5 to 10 meters per second. And the wind speed increase up until 500 meters. And if we think about the sea breeze, we illustrated that the height should be up to 300 meters, which doesn't align, and there's no big shift in the wind direction, which if it's a sea breeze, it should shift from north and east to the west, but there is always north, which the wind direction doesn't align, and the minimum speed 5 to 10 meters per second is too low for sea breeze, which doesn't align. So those three reasons give us the hint that the graphs showing there is not a sea breeze. And question C is follow-up of question B. So based on the change in wind speed with height, which is this graph, estimate the surface roughness height and compare this to the terrain category in standards Australia, which is Australia standard 1170. So first we follow the instructions. What's the general trend in wind speed with height? So we can pick up this section over there. And the gradient of this, we can compare the gradient of this with the section 4.2, table 4.1, the terrain MZCAD, the terrain or height multiplier. So we say it's so we can pick up 2 points. So we can pick 1 point there at 10 meters per second, and here, so 10 meters per second correspond to 100 meters, and this is 200 meters correspond to about 12 meters per second. So we can get the slope 12 over 10 divided by 200 minus 100, which is equal to 0.02. And if we compare with this graph, we can see it doesn't align with the graph. So the answer here is the slope doesn't align with table 4.1 in Australia standard, because the Australian standard is based on extreme event. And this breeze over there is very far from an extreme event. So if you show the calculation and state that it doesn't lie because an Australian standard is based on extreme events, you will obtain the full marks. So this is the end of the first question. Thanks for watching.